What's going on, everyone? Welcome back to Take It Apart channel, and today I have something very near and dear to my heart that we are going to take apart because I gotta know how it works. And I'm talking about my Atlas leaf blower. This guy has served me well for many years, and there's a few quirks that it has started to have. I can't really describe them because, oddly enough, it doesn't do it that often, and it seems like the symptoms change every single time. So I pulled off the battery, pulled off the snorkel, the tube, and we're just going to open this bad boy right up and see what's going on inside it. All right, let's do it. Here we go. I thought first that this was going to be a Phillips screwdriver situation. However, looks like they're T20s. And lots of them. It's alright. I dig Torx. Torx are stronger than Phillips, that's for sure. Interestingly enough, the back half of this, there's nothing in there. It's all just an air cavity because this thing will get starved for air very easily. It moves so much air. This is just insane how much air this thing can move. And it needs that large cavity to create like a buffer. Now it does have a couple things that I want to take a look at. One of them is it's got this feature, I guess you can call it, where when it's fully occluded or when it's almost fully occluded, it senses somehow some level of pressure and it just completely staves off the motor RPMs, and it senses that. And I want to know, how does it sense that? Is there like a differential pressure sensor, or is it actually sensing that the fan is pushing harder than it normally would have to, like it's pulling a quantity of amps? I don't know. We're going to take a look and see if that's something that we can diagnose. Now there's been a couple times recently where this guy ended up having a completely drained battery, because I normally hang it on the wall back here behind me, and I pulled it off the wall and I went to use it and it had a completely drained battery, and that is not like me at all, folks. If I put something on the wall, it's got a brand new battery, and it's so that I can grab it easily and quickly. So it's got like a parasitic loss sometimes on the battery, and that's something that I will be able to measure when we get in there. We can actually sense when it's in the off condition how much drain is on the battery. We can put something in line to the battery and measure the amps. All something we might do. Now the goal here is to pull it apart, see what it looks like on the inside, and put it back together, folks. I use this thing almost daily. I mean, that's how I clean my garage. That's how I do so much stuff with this guy. And obviously the hurricane today made me want to use it today. Okay, so I can see over here that there are some little plastic latches. Boop. That are retaining a safety grid. See that guy? So that is so people don't stick their little fingers in there. And that grid also might be responsible for creating a semi-laminar airflow. You see that? So, in other words, what it does is it concentrates the air and it keeps it linear, because air is naturally turbulent, especially when it comes off of a motor or a fan. Air is very turbulent. So this might be a kind of grid that would stabilize the air, and you can see it's tapered a little bit, a tiny little bit. So it does focus the air. So let's hope that that's what it's for. Okay, I believe we have almost everything out. I got this Phillips right here. Okay. This is a variable throttle, supposedly. However, all it really is a little tang that comes off, and it locks down the trigger at a certain percentage. You can see the little slit in there. how it obstructs it at a certain level. And you can lock it down so the trigger stays going. You have to grip it. That's the concept here. Is it will force the trigger down to a certain percentage, and that's this variable throttle control or throttle maintenance. The cool thing about this guy is it is a 40-volt lithium battery, and it does have a very nice variable throttle right here, so I can really lightly luff the air. I got all the fasteners out, but I'll show you. So you can hear it goes really slow. That's as slow as I can get it right there. And then it goes extremely fast. And it just blew my microphone right off the table. Sorry about that, guys. Alright, so let's pull that battery off before we start electrical fire. It has a series of terminals on the rear end. And the camera, of course, isn't going to pick it up because why would it? Those terminals interface with the battery, and you can see the far ends are pluses and minuses. Doubles up on the terminals so that you could handle a wider variety of current. And then the middle terminal here is ohms and C. And I wonder if that's for internal temperature monitoring on this guy. Notice this one has a couple extra terminals that are not being used. This one and this one. This one and this one right here. They're not being used because there isn't even anything in those slots in the battery. But in theory, it would help share the load for current. All right. It's ready to be taken apart. Hopefully, it is nice and just separates. Oh, very cool. Okay. Here in the nose, you see that we have some clips, some retention clips, which you guys probably predicted that they were going to fly across my desk, and they did. I aim to not disappoint, that's for sure. There we go. So that's what the clips look like. There we go. Now it'll come across a little bit easier. Let's see, is there another clip over here that I'm unaware of? No. It appears to be sticking a little bit here at the handle. Okay. Just a little bit of goo juice or something kept it in there. All right, there we go. So inside this guy, we have some dampeners right here, and they're going to interface with the plastic, probably because when this guy gets going, there's some vibration there. So that would be how this guy is softly mounted to the frame, and it doesn't transfer all those crazy vibrations up here to your handle. Interesting. The handle is placed at a very comfortable level. It's got lots of supports up inside it, and it's got some butylene rubber overmolding. Dig it? I dig it. Overall, it's pretty well made. ABS plastic. Let's take a look at the guts of her. All right, well, as I said earlier, that there was extra terminals here. Hold on, let me get my demonstration driver so that we can point things out. There we go. So this terminal right here and this terminal right here, you see positive, negative, and on the battery, you get 2 positives and 2 negatives, right? However, you can clearly see that they are not putting them in parallel. They only have the outermost terminal soldered right here and right here. Those are the only ones. Now, I would normally think it's drawing so much current that you would want both blades to be utilized because you have 2 blades, 2 sockets right here. So you can split the current amongst the terminals, but apparently that's not necessary. I do see that there is some strain on the wires. Take a look right here. You can see that there's some crimp from the plastic on these wires, and that over time is not a good thing. There's no shrink tube on the middle wire, That's the terminal that I mentioned. That was for ohms or C, which would be probably thermistor of the battery. So in case the battery gets too hot, it probably signals right here, hey, shut off. So I guess that's a battery safety feature. Oh, yes, sir. All right, we got some odd choices here, man. Odd choices. Okay, so on our red wire right here, we have, what gauge is that? It says 105 degrees C, 300 volt. AWM. It looks like it's a 18 gauge, this wire. And oddly enough, this next wire down here, wait. So we have, no, it says that, I don't know how that's possible because it looks like it's too thin of a diameter. Unless, you know, some of these Chinese products, they don't exactly label things correctly. They're saying that this one here is a 14 gauge. This smaller negative wire is a 14 gauge. It looks like it's an 18 to 20. All right, it's that small of a diameter. In fact, hold on. There we go. Behind the magic curtain. Let's take a look. All right, let's be scientifical. It says that it is 300 volt, 16 AWG. God, I just don't see it. It's too thin. I have 2.4 millimeters on the outer jacket. Now, the outer jacket changes things, right? It could have a thick, could have a thin outer jacket. The only real way is to open it up and check the inner diameter. I can see right here that it has a thin outer jacket, and it does seem to have quite a bit of conductor on the inside. I do not see that as being 16 gauge. I'm saying 18. And this large red wire here, I am not seeing a gauge reading on it. It says AWM something something something. I got 300 volt, 105 degree. 14 gauge? It says it's 14 gauge. That seems a little more plausible. If you were to realistically see the size difference of these two, they're quite different. So let's see. I got two on the negative wire. I got 2.3, 2.35 millimeters. And I have 3 millimeters on the red wire. I don't know. I'll have to look that up. Just doesn't feel right. Now, normally you would think that the positive and negative would have equal gauge, right? Because current's going to go in one wire and it's going to come out the other, right? Is my laws of electrical principles, are they all wrong right now? So they got 3 different wire sizes here. They have a blue wire, which is the monitoring wire. You got a negative wire, which is 18 gauge or 16 gauge, they say. I'd say it's 18, but and then you got this one that says it's 14 gauge, which still seems a little. It seems maybe a little too small, but whatever. Okay, and let's see. We have over here the brain box. We have our variable trigger, which is connected to a 36 volt 20 amp variable switch right here. And these wires are staked on. Interesting. So they put a terminal that is crimped on there, and then they like spot weld it to the switch. I guess that's one way to minimize the amount of heat, because heat would damage the switch. I guess that's one way to do it. Oddly enough, they go from a large gauge. What the hell is that? They go from a large wire here on the switch to a small wire to the brain box. You see that? This is all over the place. And they got a crimped on terminal there. That's so wild. They didn't even have to use, I mean, because if you think about it, I guess most of the current is going to go into the switch. You would normally think that they'd use the same diameter wire all the way through. Guess that's not in the cards. Okay, let's pull. Okay, so here is the input focusing ring. And our little jet terminal. Now mind you, this, according to all the advertisements, this is a brushless system, which I agree, it is, as far as I can tell. Hold on, we'll take a look at it in a moment. Alright. Oh, so sad to see it that far apart. Okay, here we go. This is the magical little brain box. They have a couple rather large electrolytics. A very healthy heatsink, because I know when I use this guy, it's under a prolonged period of time, and I like that turbo button. You know, I really dig it. Tell you what, just because I'm a nut like that, let's see what happens when I plug it in. And I hold the motor. Yeah, all the things you're not supposed to do, right? Okay, here we go. So that you guys can see all the fancy dancy stuff. So this right here is my little switchy switch. It closes the connection. Wait. This is a weird switch. So on one side, you obviously have a variable resistance that's going to go in here into the brain box and tell it what it needs to do. And on the other side, you have a wire coming in and a wire coming out. So it, no matter what, it disconnects the mains or the battery from the bread box, the brain box. This guy, it disconnects it when you let off completely. So that's what you're doing. When you let off, it disconnects one of those wires. And then when it is connected, when you depress it, I don't know, I'm depressing it about a quarter of the way. That's when it feeds the resistance to this guy, which tells it its variable speed. You have 3 wires going to the motor. It is a brushless motor, and that motor is not as big as you would think it would be. Come on. Come on. The cone, which helps regulate the airflow. There it goes. Being a little bit of a pain in the butt. You can see that the motor's sizable. It's got a hefty bearing that looks like a sealed bearing on the rear end of it. I was gonna say the ass end of it. Yeah, it's got a large caged bearing that's on the rear, and you can tell the motor just kind of slides down in there. And I guess that I'm looking for some sort of airflow that goes around that motor to help with the cooling. I don't really see it, man. Huh. So hopefully that motor just doesn't get too hot, right? This thing moves a hell of a lot of air, okay? It moves so much air. And maybe that is what helps cool it down. Okay. So that is the induction. And the cone is on the exit side. What? Self-explanatory, right? There we go. So that is a focusing cone to help eliminate what I already said earlier was going to be the turbulent airflow. This is the induction side. And I'll tell you, it has quite a bit of gallop. So this right here, this little guy is my turbo. So let's see how this goes, where I depress this guy and then I hit turbo. Here, let's do it this way so y'all can see it. It wants to take off like a jet. Okay, ready? Let's do it again. That's just too much fun. Very dangerous. Wow, this This thing is screaming. Oh my gosh, how much fun can you have with this? All right, now, for safety's sake, let's disconnect the battery. Okay. Now what I wanted to do for this guy is it's a 3-phase motor and motor controller that has a variable throttle and a turbo feature. What could we possibly use that for other than a boring blower? Power wheels, boys. Power wheels. They have 3-phase motor conversion kits for Power Wheels. I got some 3-phase motors over here. And the cool thing is that we can hook a 3-phase motor up to a Power Wheels and give it variable throttle and turbo. Turbo, good stuff. I dig it, guys. Now, let's see if I disconnect the throttle right here, will it still power on? Like, will it go default, like, flat out? Let's find out. How dangerous, right? How fascinating! That is so fascinating. Why is it fascinating? Well, because when you disconnect the variable throttle right here, it starts out extremely low RPM generally, and it speeds up on its own. You can hear it. It's gradually increasing RPMs. It just doesn't know how high it's going to go. I bet you this thing goes all the way. Let's disconnect that guy because I didn't think it was going to run at all since the throttle was disconnected, but it not only will run, it will run probably until the darn thing falls apart. Anyway, guys, that was fun. That was a lot of fun. I've always been curious about what's inside this guy. I actually really dig the Atlas tools from Harbor Freight. I've got a whole fleet of them, from the hedge trimmer to the string trimmer. I've got this blower, I've got the mower, I've got the whole entire fleet that revolves around these 40 volt and 80 volt batteries. Huh. I bet you that's why it's got the double positive and double negatives. It's 40 volt or 80 volt. I bet you. Oh my gosh, guys. What do we do? Maybe I really dig this tool. I love this tool. However, curiosity killed the cat, and you know, I've got a cat who seemed very lively. So I'm thinking that I might be doing a video in the very near future where we upgrade the kids' ride-on toy to a 3-phase. That sounds like fun, huh, guys? Anyway, there you have it. That is my leaf blower torn apart from Atlas, 40 volt, 80 volt, whatever you think it is. I think it's 40 volt on this guy. It's so powerful, and it's so extremely dangerous. And to think, I have everything I need right here to actually have some fun with hacking other toys. Anyway, guys, that's for another video. Thank you for watching, and I'll see you next time on Take It Apart channel.